Hello, friends. Grab your coffee, grab your cookie, and do not sneeze near any open bags. Because today, we are talking about dye powder dust. Yes, the colorful, beautiful, innocent-looking dust that somehow manages to stain your clothes permanently, coat every surface within 50 feet, and make your facility look like a rainbow exploded in it. My name is Michael Klepik, and for 15 years I have been building dust collection systems for pigment factories, plastics plants, paint and coating operations, printing ink manufacturers, textile dye processes, and colorant packaging lines. Today I will break down what dye powder dust really is and how we keep it under control. What dye powder dust really is. Technical description. Dye and pigment dust are extremely fine particles made from organic dyes, inorganic colorants, metal oxide pigments, and specialty powders used in plastics, paints, inks, and textiles. Technically, first, particle sizes often range from 1/10 of a micron to 10 microns, and sometimes even smaller. Second, bulk density varies widely from 200 to 800 kilograms per cubic meter depending on chemistry. Third, airborne concentrations can reach from 1,000 to 20,000 milligrams per cubic meter during mixing, dumping, and packaging. Fourth, many dye powders contain organic molecules that can be combustible. Fifth, the particles are extremely lightweight and remain airborne for long periods. This makes dye dust one of the lightest, stickiest, and hardest to capture industrial dusts. Where dye and pigment dust appear in industry, you will find dye powder dust in almost every color-making operation. First, powder dye blending for plastics and master batch production. Second, pigment grinding and micronizing processes. Third, dry powder mixing and color formulation. Fourth, bag dumping, barrel emptying, and small portion dosing. Fifth, printing ink powder preparation. Sixth, textile dye powder handling before solution mixing. Seventh, powder coating factories and colorant packaging lines. If the material is colorful and dusty, chances are it is a dye powder. Why dye powder dust is dangerous? The danger comes from both chemistry and particle size. First, the particles are small enough to reach deep into the lungs. Second, many organic dyes are combustible as fine powders. Third, some pigments contain metal oxides that are respiratory irritants. Fourth, dye dust can cause sensitization, allergies, or skin reactions. Fifth, colorant dust easily coats sensors, electronics, and production lines. Sixth, the smallest fraction behaves like smoke, creating visibility issues, in other words, beautiful colors, serious hazards. Physical behavior of dye powder dust in airflow. From an engineering perspective, dye dust behaves like no other. First, it is ultra-light and gets airborne from minimal motion. Second, it generates static electricity that makes the dust cling to surfaces. Third, it easily leaks through small gaps if hoods are not enclosed. Fourth, it forms clouds that move unpredictably with airflow. Fifth, it stains ductwork, filters, and equipment permanently. To prevent accumulation, I designed duct velocities from 4,500 to 5,500 feet per minute. What filtration equipment works best? Because dye powders are so fine, filtration must be extremely efficient. For ultrafine dye dust, I primarily use FOEHN cartridge collectors. First, they provide very high filtration efficiency for particles below 10 microns. Second, they offer a large filtration area and a compact footprint. Third, they pulse clean effectively, even for fluffy pigments. I specify fine media, often with a special membrane coating to prevent dye particles from embedding into the fibers. For heavy loading or mixed dust, a BagHouse blizzard is ideal when, first, pigments include both fine and coarse particles. Second, the process generates continuous high loads. Third, long operating cycles demand rugged construction, explosion protection. Because many organic dyes are combustible, I include, first, explosion vent panels. Second, grounding and bonding to eliminate static. Third, isolation valves to prevent flame propagation. Fourth, anti-static filter media. Capture methods for dye powder processes. Source capture is absolutely essential. The most effective approaches include, first, enclosed hoods around powder mixers and blenders. Second, downdraft tables for small batch preparation. Third, bag dumping stations with built-in capture plenum. Fourth, sealed glove box enclosures for high-purity dyes. Fifth, multi-point extraction along conveyor transfer lines. Improper hood design is the #1 cause of escaped pigment clouds. The most common mistakes I see with dye powder dust. Across many colorant facilities, I repeatedly see, first, using standard filters that cannot capture ultrafine particles. Second, not enclosing mixing or dumping stations fully. Third, ignoring combustible dust requirements. Fourth, not grounding equipment causing static sparks. Fifth, running too low duct velocity causing dust deposition. Sixth, allowing operators to handle powder in open air. These mistakes lead to contamination, exposure, and even explosion hazards. What I always do on dye powder projects, my standard approach includes: first, identifying exact dye chemistry, organic, inorganic, or metal oxide. Second, measuring dust generation and particle size distribution. Third, designing high-velocity duct systems to keep dust moving. Fourth, selecting ultrafine cartridge media with membrane coating. Fifth, adding explosion protection when required. Sixth, ensuring all hoods and stations are fully enclosed. Seventh, providing easy-to-clean surfaces to prevent staining. This combination ensures clean air, long equipment life, and consistent product purity. Dye powder dust is colorful, beautiful, and incredibly dangerous if not handled correctly. It is ultrafine, airborne, sometimes combustible, and always messy. But with proper capture design, high-efficiency filtration, and explosion protection, it can be controlled safely and reliably. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, the only place where bright colors should fly is in your artwork, not in your air ducts. See you in the next video.